Hello everyone, I am Bikash from Group 9 of Data Mining Project. My other team members for this project are Nitin, Chandan and Chintan. The topic of our project is prediction of bike sharing demand. Now, what is bike sharing? Well, bike sharing system is a system where a person can pick up a vehicle on rent from one bike station and can give it back at another bike station. Bike sharing rental process is highly correlated to the environmental and seasonal settings. For example, weather conditions, precipitation, season, hour of the day, etc. can all affect rental behaviors. The data set for this project has been obtained from one of the Kaggle competitions. The data is real time and is taken from one of the companies implementing bike sharing systems named Capital Bike Share based in Washington DC. The data comprises of all the bike rental counts for Washington for the year 2011 and 2012. We have been provided with two data sets for these projects, one hourly and the other one is daily. A sample screenshot for the hourly data set is mentioned in this slide. It contains several attributes like season, year, month, temperature, humidity, count, etc. Count will be our target variable in further slides. Now, the major objectives we had in our project were two. One, to analyze the data set and determine change in bike rental trend and peak hour of bike rental. Secondly, predicting the bike rental count based on different weather conditions using different data mining algorithms. We had used Tableau for analyzing data in this project. Analyzing data is very important for deriving patterns within data, for building relationships between various attributes, also to find out any kind of discrepancies within data like missing values, etc. Now this is one sample screenshot of the Tableau visualization. This one is for count of bikes rented versus seasons. As we can see, there are four seasons: spring, summer, fall and winter, named as 1, 2, 3, 4 in sequence successively. We can see the count of bikes rented is very small for spring as compared to other seasons. So this is one output we can take up from the Tableau visualization. Now in this visualization, we have got the registered and total bikes rented versus the weather situation. I mean how the count behaves on different weather situations. When the weather is clear or partly cloudy, the count we can see is highlighted by the blue color is very high as compared to when it is heavy raining or snowfall, the count is negligible. This graph shows the distribution of or rather demand of bike rented each hour. Now as we can see, the demand of bikes is very high during the 17th hour, that is evening 5 p.m. The second high demand is comes at 6 p.m. in the evening, then at 8 a.m. and so on. Now this is one more Tableau visualization which is registered versus total count of bikes versus across all the months of the year. We can see the demand for bikes is very high during the month 6, 7, 8, 9, which is June, August, September and July. Now further we will be discussing about all the models used in data mining, for which Nitin will be proceeding the video.
Thanks, Bikash. This is Nitin here. Now we will see various data mining models used here. Most of the variables have outliers which influence the correlation or the regression. Taking the log can help this by reducing or eliminating the skewness. Using the SAS code, we created new variable whose value is computed by using log function. We created a linear regression model using the log value of count and the input variable, that is the log humidity. From the plot we can see that the predicted value of the log count decreases as we increase the log humidity. Thus people tend to register more bicycles when there is a less humidity. In multiple linear regression, we created the model using SAS code between the log values of the count and the log values of temperature, humidity, and wind speed. This graph plots the predicted values of the count when log value of temperature is inserted into this equation of multiple linear regression. Positive and negative slope of the independent variable shows increasing and decreasing behavior, respectively, against the log value of the count. Here we created a new target variable which is binary nature. We took a threshold value of 4500. If count is greater than 4500, the newly created target variable is 1, otherwise 0. Using this data set, we removed last 20% rows and created a scoring data set, which is used for predicting the values of target variable data in the project. Now this training data set is divided into two parts, with 70% allocated for the learning the model and the rest for validation. We created a model using decision tree, where we modify the parameters like maximum number of the generation of node, leaf size, etc. A pruned or the optimal tree is created as shown in the slide. In the plot, we can see that as the number of the leaves increases in the training set, the misclassification rate decreases. For validation set, the misclassification rate is higher than that of training data set. But the blue line indicates the optimum number of the leaves required for the pruned best tree. As mentioned before, there are variables which have outliers. These variables are transformed using the log function. These transform variables are used for creating a logistic regression model. In logistic regression, probability or odds of the response taking a particular value is modeled based on combination of values taken by predictors. Further, you can see the misclassification rate for the training dataset as 10% and 17% for the validation dataset. We also implemented neural network. Neural network usually produce best accuracy in terms of low misclassification rate. We modify neural network properties like changing direct connection from input to output to yes and the number of hidden units as 5. You can see the neural network has produced 3% as the misclassification rate for training dataset and 16% for the validation dataset. Furthermore, we also implemented auto neural network. This model conducts limited search in order to find the better network configuration. Here you can see the misclassification rate for the training and the validation dataset, which is 6% and 12% respectively. All these models are then combined and then compared as shown in the slide. After comparison, we see that the auto neural network has been selected as a champion model or the best model among the others, having minimum validation misclassification rate as 12%. Now in this slide, we also predicted the value of the target variable of scoring dataset using score node and SAS programming. As mentioned before, the score node is the dataset having last 20% of number of rows from original dataset. We can compare these predicted values with the last 20% of the rows in the original dataset. These are the predicted values using the score node, manually mentioned here for comparison. As you can see, there are very less number of wrongly predicted binary values. Lastly, the business recommendations. As previously explained, spring season has the lowest number of registration, thus the lowest sales. Business recommendation could be giving out some discount or any kind of incentives to increase the percentage of sales. Secondly, if we want to reduce the imbalance of physical distribution of bikes, we can track the demand of bike using GPS units during the peak hours. Thank you very much for watching the video. Have a nice day ahead.